Today, we'll learn about integration by substitution through 3 problems shown on the screen. Alright, here's the first problem. Integral of x times square root x plus 2 dx. Before directly solving the first problem, let's first examine the integral of u minus 2 times square root u du on the right. Do you notice the difference between the two problems? The left problem has two terms inside the square root, x plus 2, making the integration challenging. On the other hand, the right problem has only one term, u, inside the square root, making it more accessible. Expanding the parentheses on the right, we get the integral of u times square root u minus 2 times square root u du. Simplifying the exponents, this becomes the integral of u to the power of 3 over 2 minus 2 times u to the power of half du, making the integration straightforward. Integrating each term yields u to the power of 3 over 2 plus 1 over 3 over 2 plus 1 minus 2 times u to the power of half plus 1 over 1 half plus 1 plus c, which can be further simplified to u to the power of 5 over 2 over 5 over 2 minus 2 times u to the power of 3 over 2 over 3 over 2 plus c. You can simplify the expression by multiplying both the numerator and denominator by 2. Then it will be 2 times u to the power of 5 over 2 over 5 minus 4 times u to the power of 3 over 2 over 3 plus c. We quickly solved this integral because there was only one variable u inside the square root. However, the left problem has x plus 2 inside the square root, making it challenging for quick integration. But what if we could substitute x plus 2 with a single variable, say u? Let's try that. If we substitute u for x plus 2, x becomes u minus 2 and dx over du is 1, making dx and du equivalent. Now let's substitute x with u minus 2, x plus 2 with u, and dx with du. This transforms the problem into the integral of u minus 2 times square root u du, which turns out to be the same as the problem we solved on the right. Do you see why we needed to substitute u for the square root inside x plus 2? As we did on the right, it was possible to simplify by expanding the parentheses and expressing it as independent terms of u. The result of this integral with the u-substitution is 2 over 5 times u to the power of 5 over 2 minus 4 over 3 times u to the power of 3 over 2 plus c, which matches the expression we obtained on the right. Now the remaining task is to revert u back to the terms involving x. Therefore, the final answer is 2 over 5 times x plus 2 to the power of 5 over 2 minus 4 over 3 times x plus 2 to the power of 3 over 2 plus c. Now let's look at the second example, the integral of x over x minus 4 to the power of 4 dx. Is it immediately integrable? It seems challenging. How about the integral on the right, u plus 4 over u to the power of 4? Can you integrate that easily? Yes, if we express it as two fractions, the integration becomes more manageable. It becomes the integral of u over u to the power of 4 plus 4 over u to the power of 4 du, which simplifies to the integral of u to the power of negative 3 plus 4 times u to the power of negative 4 du. Now, we can easily integrate each term, resulting in u to the power of negative 3 plus 1 over negative 3 plus 1, plus 4 times u to the power of negative 4 plus 1 over negative 4 plus 1 plus c. And this simplifies to negative half times u to the power of negative 2, minus 4 over 3 times u to the power of negative 3 plus c. Since there is only one term in the denominator, u to the power of 4, we can easily separate it into two fractions for integration. Now, what about the left problem? Can we express the x minus 4 to the power of 4 in the denominator as a single term? Yes, if we substitute u for x minus 4. If u is x minus 4, then x becomes u plus 4, and dx over du is 1, so dx equals du. Substituting u plus 4 for x, u for x minus 4, and du for dx, the integral becomes u plus 4 over u to the power of 4 du, which matches the problem on the right. Therefore, the result should also be the same. The integral result is negative 1 over 2 u to the power of negative 2 minus 4 thirds times u to the power of negative 3 plus c. Now, substituting back u is x minus 4, the final answer is negative half times x minus 4 to the power of negative 2 minus 4 over 3 times x minus 4 to the power of negative 3 plus c. Do you see the difference between the two problems? Can you see why we needed to substitute u for the denominator x minus 4? It was to simplify the seemingly complex problem into a simple function of u, similar to what we did with the problem we solved earlier. Now, let's consider a slightly different example. This time, let's solve a definite integral problem using substitution. Since the integral on the screen seems challenging, we need to decide what to substitute. A. Substitute u for 2x minus 1. B. Substitute u for square root 2x minus 1. Which would make the problem easier. I will solve both and compare, then guide you on which one to choose. A. Let's define u as 2x minus 1, then x is u plus 1 over 2, and dx over du is half. Thus, dx is half du. However, when using u-substitution in definite integrals, we need to be cautious about the integral limits. In this problem, x ranges from 1 to 5. When you substitute u, we need to adjust the integral limits accordingly. When x is 1, u becomes 2 minus 1, which is 1. And when x is 5, u becomes 2 times 5 minus 1, which is 9. Therefore, u ranges from 1 to 9. Now, let's substitute all x variables with u in the integral. The integral now ranges from u is 1 to u is 9. The numerator, which was x, becomes u plus 1 over 2, and denominator square root 2x minus 1 becomes square root u, and dx becomes half du. Factoring out the quarter outside the integral, we get 1 over 4 times the integral of u plus 1 over square root u du. And this can be u over square root u plus 1 over square root u if we write them in two fractions. We can express this simpler, 1 over 4 times the integral of u to the power of half plus u to the power of negative half du. Now, integrating each term, we obtain 1 over 4 bracket u to the power of half plus 1 over half plus 1 plus u to the power of negative half plus 1 over negative half plus 1 from 1 to 9. When you simplify the bracket terms, it becomes 1 over 4 times bracket u to the power of 3 over 2 over 3 over 2 plus u to the power of half over half. And multiplying each term by 2 in the numerator and denominator, we get 1 over 4 times 2/3 times u to the power of 3 over 2 plus 2 times u to the power of half from 1 to 9. Now, we can easily find the value of the definite integral. The expression becomes 1 over 4 times 2/3 times 9 to the power of 3 over 2 plus 2 times 9 to the power of half minus 2/3 times 1 to the power of 3 over 2 minus 2 times 1 to the power of half, which simplifies to 1 over 4 times 2/3 times 27 plus 2 times 3 minus 2/3 minus 2. Evaluating the expression in the parentheses, we get 1 over 4 times 18 plus 6 minus 2 over 3 minus 6 over 3, which further simplifies to 1 over 4 times 24 minus 8 over 3. Removing the parentheses and multiplying by the 1 over 4 in front, the final result is 6 minus 2/3, equivalent to 18 minus 2 over 3, which is 16 over 3. The explanation may seem a bit long and complex, right? Now let's solve the problem again by substituting the entire denominator square root 2x minus 1 with u. First, squaring both sides to get u squared is 2x minus 1, and solving for x, we find x is u squared plus 1 over 2. Then let's find dx over du. It's straightforward, and we see that dx over du is u. Now, let's examine the integration bounds. For x, it was greater than or equals to 1 and less than or equals to 5. Using this information, let's determine the range for u. When x is 1, u squared is 2 minus 1 equals 1, so u is plus minus 1. However, as we substituted u with square root 2x minus 1, and square root cannot be negative, u takes only positive values. Thus, u is 1. When x is 5, u squared is 2 times 5 minus 1 equals 9, so u is 3. Now, we have the integration range for u as 1 to 3. Let's calculate the definite integral. The range of u is 1 to 3. the numerator x becomes u squared plus 1 over 2, and the denominator square root 2x minus 1 becomes u, and dx is replaced by u times du. Simplifying, the integral becomes half times integral u squared plus 1 du. This integral is now simpler compared to before. Evaluating, we get half times bracket u to the power of 3 over 3 plus u from 1 to 3, resulting in half times 27 over 3 plus 3 minus 1/3 minus 1. Simplifying the values inside the parentheses, we get half times 9 plus 3 minus 1/3 minus 3 over 3, which further simplifies to half times 12 minus 4/3. Expanding the parentheses, we get 6 minus 2/3. Therefore, the final answer is 18 minus 2 over 3, which is equivalent to 16 over 3, the same result as before. We have explored integrating using two different substitutions, and we've discovered that the second method is much simpler in the calculation process. The choice of which terms to substitute with u may vary depending on the problem, but ultimately, the crucial factor is whether we can easily transport them into simple functions of u by multiplication or division. Today, we delve into basic substitution integrals. In the next session, we'll explore a wider range of integration by substitution. If this video was helpful, please like and subscribe. Until the next video, this has been your Math Guardian, Alex.